let's learn another derivative shortcut rule. In fact, let's learn two. We're in section 3.2, we'll be learning the product and quotient rules. Just for some quick review, let's find these derivatives. Remember our notation for the derivative of y is dy over dx. I'm writing it negative 21 x to the 6th plus 2x to the negative 3. Here, dy over dx is going to equal, well, actually, I'm not quite sure what that is off the bat, but we do know that y equals root 7 times x to the negative 1. So dy over dx equals root 7 times negative x to the negative 2, which is negative root 7 x to the negative 2, which is negative root 7 over x squared. Here, we can rewrite f of t as as equals root 8 t to the 84th plus 7 t to the negative 1/2. So f prime of t equals 84 root 8 t to the 83rd minus 7/2 t to the negative 3/2, or 84 root 8 t to the 83rd minus 7 over 2 t root t, or the square root of t cubed. And then here we have dy over dx equals easiest derivative ever, 2 to the x. Okay. Anyway, what is the derivative of this guy? Pause the video, try to do it. Well, there are two ways to do it, so tell me which one you prefer. Option 1, f prime of x equals, well, it's going to be the derivative of 5x cubed times the derivative of negative 2x to the negative 6. That's 12x to the negative 7. And I guess we can do that out. I think that's going to be 180 x to the negative 5th. Or 180 over x to the 5th, whichever way you want to say it, okay? So that's option 1. Option 2 is, well, I guess we could multiply this out, and we get negative 10 x to the negative 3, right? Just to be clear how I got that, I did 5 times negative 2 x cubed x to the negative 6, which winds up being negative 10 x to the negative 3. And so from there, f prime of x equals 30 x to the negative 4, or 30 over x to the 4th. Well, which one is correct? Well, if you think about it, here we made an assumption that we could just take the derivative of each part of the product, right? Each factor. That the derivative of the product was the product of the derivatives. That's a leap. We're not sure we're allowed to do that. Whereas here, we didn't actually make any assumptions. We did the same thing we were doing before. So it turns out this is correct and this is not. So then the question is, well, again, that wasn't so bad, but what if the product were more complicated? Or what if it weren't simplifiable? What if it were something like problem 1 where we have that? You can't simplify that. So what's its derivative? So for this, we have to learn the product rule. Okay. Now for this, you definitely need to know the product rule. The product rule says that the derivative of the product of two functions is the derivative of the first, leave the second alone, plus the first, leave the second alone. Okay. Now at this point, you can just fast forward a minute or two of the video where I'm going to derive the product rule. Okay, I'm just going to derive it. The way you derive the product rule, well, you might imagine it's, just to be clear, this is the derivative of f of x times g of x. That might be clearer notation. So we're going to have the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x, g of x, all over h. And we have to somehow show that we get this. So it might not be clear how we're supposed to simplify. One thing in mathematics that can be really powerful is adding 0. That's right, adding 0. Now, what do I mean by that? What if we consider this? I'm going to subtract f of x times g of x plus h from the top. Well, I guess if I'm going to subtract it, then I need to add it back on. Does everyone see what I did there? I just subtracted it and then added it back on. So I added 0. Right? It's definitely a bit of trickery, but it is legal. I added 0. We're always allowed to add 0. Right? Well, why would I do that? Well, now that I did that, I guess we could split the fraction kind of nicely, right? We could write this as f of x plus h, g of x plus h, minus f of x, g of x plus h, all over h plus f of x, g of x plus h minus f of x, g of x over h, right? Right, and I guess, using some simplification and maybe some limit laws, maybe we see that we're allowed to do the following. I'm going to actually write this over here because I think I'm running out of room. We're going to get f of x plus h, well, let me first lower this a little bit, minus f of x, actually I want to do that, divided by h, and then this is all being multiplied by g of x plus h, right, if I can factor out a g of x plus h. And then I guess using limit laws, I'm allowed to then make this a limit, provided it exists, which we'll see in a sec that it does. And then I guess also using limit laws, I'm allowed to say that this is the limit as h approaches 0 of f of x times g of x plus h. Actually, I can factor out the f of x in the fraction, so I get this. Right? And I guess if you think about it, I could factor the f of x out of the limit altogether. Right? So I could write this as f of x times the limit as h approaches 0 of that. Right? So we have that. And when we simplify, well, we wind up getting that this whole thing right here is f prime of x. This second term right here is g of x, right? Just g of x, just plug it in. And then here we have f of x, and then here we have g prime of x, right? Everyone see that? This right here is f prime of x. This right here is just g of x, and we take the limit. This right here, this right here is f of x, duh. And then this right here is g prime of x. So we proved the product rule. So, what's the derivative of g of x equals x to the fifth times e of x? Well, g prime of x is going to equal the derivative of x to the fifth, leave e to the x alone, plus, now leave x to the fifth alone. Now it turns out the derivative of e to the x is itself. So that's our answer. What about these derivatives? Well, let's try to do these really quickly, right? So f prime of t, right? Notice to identify your f of x and your g of x, right? is going to equal, so the derivative of t to the 1/2, right, note that this is t to the 1/2 e to the t. It's going to be 1/2 t to the negative 1/2 e to the t plus, right, this is t to the 1/2 e to the t. Right, looking at this one, it's going to be, well, I guess we don't really know quotients yet, but I guess we could rewrite y as being e to the x times x to the negative 1. So dy over dx is going to equal derivative of e to the x, leave the second guy alone, plus e to the x, leave that alone, times negative x to the negative 2. And if you want to simplify that, then you can. Okay. Last but not least, I'm definitely not simplifying this, but this is something that would be a nightmare to try to differentiate if we didn't know the product rule, right? Imagine multiplying all that out, all 12 of those terms. It's a lot easier just to say, okay, we're just going to take the derivative of this first term, leave the second term alone, plus leave that first term alone, and then take the derivative of the second term. So it's going to be 5 minus, and then this will be 1 over, so it's 1/2 x to the negative 1/2, right? 1/2 x to the negative 1/2, or 1 over 2 root x, however you want to write it. All right, so that's the quotient, or sorry, that's the product rule. The next question is, well, what if you have something like this? You know, well, you can't write that as a product, right? You could write it as the denominators to the negative 1, but then that requires something called the chain rule. So here's another thing we have to know. This is the quotient rule. So it turns out the derivative is going to be, right, and just to be clear, this is the derivative of f of x over g of x. It's going to be low d high minus high d low all over low squared. Right? So note that unlike the product rule, there's a minus sign here, so the order does matter. That said, it's somewhat similar to the product rule, right? You just have to be a little careful. Okay, now at this point, I'm going to switch to orange because I am going to derive it, but we don't need to know this. Okay, we don't need to know this. The derivative with respect to x of f of x over g of x equals, well, you know what it is. The limit as h approaches 0 of f of x plus h over g of x plus h minus f of x over g of x. And then all over h. Right? And we can quickly rewrite this, right, as something a lot more palatable. Write the 1 over h, right? And then this is, maybe I'll use brackets. Brackets are the same as parentheses, by the way. They just look a little different, so it can be easier to separate things out. Okay. Now, at this point, what are we doing? Well, what do you think? We have a fraction minus a fraction. Use a common denominator, right? So when we do that, we're going to keep the 1 over h down here. Make this nice and big. This is going to have a common denominator of g of x plus h times g of x. And the numerator is going to be f of x plus h, g of x, minus f of x g of x plus h. Right, and maybe now you can start to see where we're going to get the sort of low d high minus high d low thing. Maybe you can see where that's coming from. Okay, but let's just see a little bit more clearly, right? What we're going to do at this point, right, and especially the divided by low squared stuff, right? We've got that g times g on the bottom there. So we still need a definition of the derivative. We don't quite have it. So again, we're going to do the bulletproof trick of adding 0. Right, so what we're going to have here, and I think actually I'm going to stick the 1 over h in the denominator. Maybe I'll even move this down a little bit more. Let's see what we're going to have. We're going to have f of x plus h, g of x, and we're going to, I'm actually going to use red so this pops, minus f of x, g of x, plus f of x, g of x. See how, again, we have added 0 into the numerator? Right? And I'm going to stick that h down here with the g of x plus h and g of x. Okay? Now, why am I doing this? Well, using a bunch of limit laws, we're going to get the following. Factor out that g of x here. We're going to wind up getting limit as h approaches 0 of f of x plus h minus f of x all over h times g of x. Oh, look, there's our f prime g right there, right? And then it's going to wind up being minus f of x times the limit. I'm doing a lot of simplification in my head right here, but namely the factoring out a minus sign. You're going to get g of x plus h minus g of x all over h. And then all of this is going to be divided by the limit as h approaches 0 of g of x plus h times g of x. And that winds up equaling exactly what we had. F prime of x, g of x, minus f of x, g prime of x, all over g of x, quantity squared. Okay? Right? So, just to be clear, another way of writing this is, again, you could write it like g of x. So you could say that, the derivative with respect to x of f of x over g of x equals low d high minus high d low all over low squared. I think this way of writing it's pretty clunky, but thinking of it this way and saying it that way is very, very handy. I've been doing calculus 20 years and I still say that. Okay? So anyway, the answer to problem 4, it's going to be, well, let's just, so the derivative with respect to x of 5x cubed plus 4 over negative 2x to the 6th minus 9x equals low d high minus high d low all over flow squared. So note that this can be a little messy a lot of the time. So like if I give you something like this, don't even bother simplifying it, right? It's terrible. Okay, just keep it like that.